friends, in this question we can see that we have to find the vector equation of the line passing through the point this and perpendicular to the two lines given to us. So for any line, vector equation general form is r vector is equal to a vector plus lambda b vector. Now here a vector is the position vector of the point through which the line is passing, and b vector is the position vector of the line parallel to the given line. Okay, so here we are aware of a vector, which is 1 2 minus 4, but we are not aware of the b vector. So we have to find this v. So let's substitute it. So a vector is nothing but I cap plus 2 j cap minus 4 k cap plus lambda times, we don't know what is b, so let us write b1 I cap plus b2 j cap plus b3 k cap. That means we have to find b1 b2 b3. The moment we got b1 b2 b3 value, equation of the line is obtained in vector form. So this is our target, to find b1 b2 b3, because a vector is already there with us. So let's see how we can find b1 b2 b3. Now I would like to visualize the question diagrammatically, that what does it mean actually. We are talking about the line, this line, and this line is having a parallel vector b vector, which is b1 b2 b3, and this line is perpendicular to given two lines. So let us say this is one line, and this is another line, and this is the third line. So in this fashion, if the position of the line is in this fashion, then we can see that this particular line is perpendicular to all the other two lines, isn't it? So obviously for L2 there will be a parallel vector, for L3 there will be a parallel vector, isn't it? And that is nothing but the direction ratios. So here we can see it is for first line b1 b2 b3. For the second line, direction ratio is 3 minus 16 7, provided the equation is in standard form. So it is in standard form, x minus something, y minus of minus 19, z minus, and abc. So abc is the direction ratio of the second line. Similarly, this is also in standard form. So here the direction ratio is 3 8 minus 5. Now we already know when the two lines are perpendicular to each other, sum of the product of their corresponding direction ratio is what? 0, isn't it? So let's write it in that form. So since L1 is perpendicular to L2, so we will have 3 times b1, then minus 16 into b2, minus 16 b2 plus 7 b3 is equal to 0. As per the condition, this a1 a2 plus b1 b2, in previous video you can see I have already discussed, when the two lines are perpendicular to each other, sum of the product of their direction ratio is 0. So that condition is applied over here. So this is for when L1 is perpendicular to L2, isn't it? Now since L1 is also perpendicular to L3, L1 is also perpendicular to L3, so we will have another this type of equation. So it will be 3b1 plus 8b2 minus 5b3 is equal to 0. Now we know that we have these two equations. Now it is very easy to find the value of b1 b2 b3 by using cross multiplication method. So what we will do, we will write b1 in 10th standard. Already we know this method, b1 upon, we will just eliminate these two terms and cross multiply the remaining. So minus 16 into minus 5, minus 16 into minus 5 minus 8 into 7, 8 into 7 is equal to b2 upon. Now just eliminate this thing, and for this case we will go from denominator from lower to upper, and then minus upper to lower. So minus so it is 3 into 7, 3 into 7 minus 3 into minus 5, 3 into minus 5 is equal to b3 upon. Now just eliminate this, and again as usual from top to bottom, then bottom to top. So 3 into 8, 3 into 8 minus 3 into minus 16. So 3 into minus 16. Now let's simplify it. So what we get, b1 upon 5 6 are 30, 5 1 is 80, minus to minus is plus, minus 7 8 is 56 is equal to b2 upon 21 plus 15 is equal to b3 upon 24 plus 48. So this we have got. So we get b1 upon 24 after subtracting is equal to b2 upon 36 is equal to b3 upon 72. Now we see that they have a common factor 12, so which this can further be simplified as b1 upon 2 is equal to b2 upon 3 is equal to b3 upon 6. 12 2 is 24, 12 3 is 36, 12 6 is 72. So b1 upon 2, b2 upon 3, b3 upon 6. So these are the direction ratio of the line whose equation we have to find. Okay, so with the help of these two relations where we had L1 is perpendicular to L2 and L1 is also perpendicular to L3, from those two relation we got the direction ratio of the required line. Now simply we have to substitute in the previous equation, which was this as written in the beginning of the solution. So b1 b2 b3 we have obtained now. So the solution is the required equation of line is nothing but I cap plus 2 j cap minus 4 k cap plus lambda times, now we know b1 is 2 I cap plus 3 j cap plus 6 k cap. So this is the position vector of the point through which the line is passing through. It was given in the question, and this is the parallel vector to the line which was required to be equation was to be found out. So this much for today. You can write any other doubt you have in the comment box, and soon I will come up with the solution. Thank you.